In our final video for section 5.2, we're going to look at a contingency table and find probabilities using this contingency table. So the data in the following table is from a study of a driver's speeding violations and age. Use the table to find the probabilities rounded to 3 decimal places as needed. So we see the rows are the 3 different age categories. The columns are whether or not they had a speeding violation in the last year. In the first column are all the people that had a speeding violation in the last year, and then the total. And the next column are all the people who did not have a speeding violation in the last year, and the total, each broken down by the 3 age groups. And then we have the totals for the 3 age groups. So the columns here should add to 950, and this last row should add to 950. Okay, in part A, find the probability that a randomly selected person out of this group would have had a speeding violation in the last year. So out of 950 people, how many had a speeding violation in the last year? It's not by age group, it's just total. So we're looking at this 85. 85 out of 950 relative to the total. 85 had a speeding violation in the last year, or a probability of 0.089. Well, from this table, what's the probability that a person in this study, and these 950 people, were in the age group of 16 to 20? So how many people were in the age group of 16 to 20? There were 360 out of the 950. If I randomly selected one person from these 950 people, the probability that I select someone who's age 16 to 20 would be 0.379. In part C, we're going to find the probability of selecting one person and they had a speeding violation in the last year and they're also age 16 to 20. I'm going to select one person and they have to meet this criteria. Both things have to be true about that one person. So where is the total of people who fit this description? How many people fit this description? They had a speeding violation last year and they were age 16 to 20. So that's going to be an intersection of speeding violation in the last year and age 16 to 20, and we see that that intersection is here. There are 45 out of the 950 people in this study who fit that description. So this is the probability that if I randomly select one person out of 950 people, that I will choose someone in that little group of 45. Okay, in part D it says speeding violation in the last year or they were age 16 to 20. Could be either one or both of those descriptions. So remember with or, we have to determine whether or not these are disjoint. If they're disjoint, they cannot happen at the same time. I just add the probability of the first to the probability of the second. But we know this can happen at the same time because we know there are 45 people who fit both descriptions. So we have to be careful not to double count. So what I'm going to do now, since I don't really need we're about done, I'm going to write all over my table now because I want to show you where are all these people. So speeding violation in the last year, that would be these people, these people, and these people. That's the total. I don't want to circle that. That's the total of these 3. And I want all the people, either those or the age 16 to 20 people. Well, here are the age 16 to 20 people. I don't want to circle this one again. We already counted those 45 people, but I haven't counted these yet. So these are the ones that would fit this description here, and these are the ones that fit the first description, because it says we either choose somebody from these three or somebody from these two groups. But we don't want to double count. We have an overlap of those 45 people who can be both. So now we need to add up 45 plus 25 plus 15 plus 315. What is that? 60, 70, 85. 85 and 315 happens to be 400 relative to the total, and we get 0.421. So remember, as long as you don't double count, you could just add these up. Okay, so you may want to make a note. These were not disjoint, so we were very careful not to double count. We wouldn't have counted 360 plus 85 because those 45 would have been counted twice. Okay, in part E, find the probability that if we randomly pick one person out of the 950, they're not age 16 to 20. Well, since we already have the probability that they are age 16 to 20, this will be easy. We can say 1 minus the probability, and I'm just going to write it, that they are age 16 to 20. Just to remind myself, these are complements. They are, they're not. Equals 1 minus, and that was part B, 0.379, which is 0.621. Use the complements to make the calculation easier. That concludes section 5.2.